Yes, good afternoon. Our project, Creative Connections, Building Bridges Between RSEs and the Arts and Humanities. The problem that we're addressing is that researchers may want to use creative methods for co-creation, collaboration, but lack the knowledge or methods to do so. And additionally, artists want to enter conversations into the use and adoption of technologies, but are often excluded from essential conversations. So the solution to that is a handbook in first instance for guidance and inspiration to cover ideas, suggestions of co-creation using arts and creative approaches to showcasing and communicating technical issues in the RSE or sustainable software field, including examples of co-creation projects. Open access so anyone can contribute and share knowledge of creative fields, domains they have experience or interest in. In addition, it's also an online platform, which was an idea and came to fruition because suddenly we had 3 web developers in our group this morning. So this is a little diagram that we created for the platform, how it looks like. 3 aspects. In the middle is a lounge where people or users would enter in the lounge. It's a space for community building and networking. There is an element of serendipity where people just meet and start connections, but also asynchronous meetings can happen there. And that happens on the left and right in the 2 other spaces. In the left is the library and the archive, a place for documentation, so for the co-creation of documents, which then can be archived. And on the right, there's a space for presentation and creation. And what we're trying to do is we try to create opportunities for people to find each other, to collaborate, but also to put a spotlight on some of the projects and people active in this space, especially exemplar projects. And that can happen in many things. One of the things that we think about is pitches. So RSEs can pitch here a project where they would like to work with an artist for, and artists can pitch ideas that they would like RSEs to work on with. Now, we had a team of a group of ostriches is a flock of 9 people, which we divided into teams, community and general input, Catherine and Kirsty. The resources, the handbook, Pauline and I worked on mostly, and then the web development. A lot of the actual static website that we will show in a bit was produced by Debs Udo, so many thanks to her. And discussions on the architecture, how it should look like, is Becca Olsterton and Roland Mosberger. And then the UI UX design, Dennis Barclay and Gila Ganyoma, including the wonderful new logo. As a workflow, we first started with a mirror board, working from the diagram, and then starting to sort of sketch out how the pages would look like, what functionality we were looking for, what architecture, what solutions, and what resources. We created a repo on GitHub. This will also be a place where the handbook will be with markdown files, so people can contribute there in an open, sustainable way. We're inviting anyone from the community to add to that. We've added the chapters. All we have to do is add the content. And then there's this sort of initial deployment that Debs has created. So this is a bit of an idea, the website. Later on, you'll see the wild ideas we have and exciting ideas for this digital platform and virtual experience. But at the moment, it is a static website on GitHub hosted there. So a little bit about the handbook that we worked on. These are sort of the main chapters: introduction, understanding creativity and research, software engineering, and the arts and humanities, speaking the same language, explaining each other's jargon to each other, finding that shared community, and then there are more chapters. For the future, this is what hopefully that website will look like, a little bit more, some beautiful mock-ups. And the last thing, this is my last slide. We are going to reach out to the RSE and Arts Humanity communities, focusing community brokers to provide feedback on the website and invite them to contribute to the development of the handbook. And this engagement or investment by those people will ensure that these individuals promote the use of these resources within their communities and areas of work.
Time.
And that was time. Thank you.
Thank you so much, Team Creative Connections. Next up, research software techniques, aka conversations over RST. Here's your microphone and timers coming up. Go.
Okay, so the problem we wanted to look at was how do you support researchers when they want to make their research software better? And we have a lot of resources for that, but there are a lot of resources for that. You know, we can't expect all researchers are going to want to go away and attend every carpentry training session that they're going to need over the course of it, or they're going to read every chapter of the Turing Way. So we wanted a quick way to get that information to them and for them to know what information they need, because the biggest problem a lot of the time is they don't know what they don't know. So we came up with the idea of having a series of simple questions that would direct them to a category of cards, and they could just look at all of these cards, and each one of these cards would have a heading of a technique or a tactic that you need for research software with a short description of why you'd want to use it. And then if this were a physical deck, the flip side of that card would have the steps showing them what they needed to do. So we spent quite a lot of time figuring out and listing out as many techniques and tactics as we could think of, and then what categories these would fit under, such as reproducibility, testing or correctness, code quality, and then figuring out how we could distill that into a question. Sorry, I was trying to see my timer now. So what we did was we had a team of 6 of us. We worked in a collaborative document for this. We had 2 people working on the sort of the implementation, the web, the app, the website style, and then we had 4 of us working mainly on these techniques, split into 2 RSEs and then 2 mainly researchers or novice RSEs who could give us that side of things. So we had a quick prototype made in Reveal.js to show you kind of how this would work. So you would have the main thing and the simple questions. So, is my code behaving as expected? See the testing category, and a series of quick questions with categories. And I'm now trying to think which category we need to go to. So how can I describe my code and how to use it to other users? Go to the documentation category. And we created at least one card in here, README. And there you get a quick example of a README, why you should have a README. And then if you go to the down, so the back of the card in a sense here, it would give you descriptions of what you need to do. So, you know, imagine you were sort of talking you through things you'd need to think about to implement a README in your code. Yeah. Sorry, we're just going to share the next machine now because we were struggling to actually get it deployed off the laptop. Okay. Do you want to talk through that, Sam?
So what became apparent is we've got quite a wide. What became apparent is we've got quite a wide audience, which meant that they had different ways of wanting to access and find the data. So you've got a kind of a very much entry level or new researcher that's starting to look at. They've got no idea of the language or anything like that. So the first view is essentially like a question and answer view. We explain the key important aspects of software development in a step-by-step process. And for each question, we ask a kind of simple question, and then there's relevant cards shown for that answer. The second way was a more pyramid type view. So you might know the categories of interest, and then you can sort of dig down into those. And finally, it was a more kind of searchable view, which meant you knew the terms that you wanted to find, and you just wanted to explore that what was there. So I started to try and actually build some of these things just to get an idea of the practicality of that and to make sure that when we were designing our data structures that was adaptable. So we've got a searchable view here, which should work. Quite simple. we have the kind of question view approach, so you can dig down into questions. Each of these things, each card is a kind of a component, so we can, I like to try and abstract the user interface from the underlying data, so we can kind of copy things across and create lots of different views. How much time have we got left? 6 seconds. And finally, the tiered view. So you've got different cards, you can kind of dig down into those. But this was just a demonstration that we'd explored the practicality of building this as an app. Thank you. Yes.
The couple of other things we wanted to say was we built our file format to work with both of those tools so that we could do our quick demo and then extend it to the full version later on, and added contribution guidelines so that people can easily extend this project and add more information or different views for their own usage. Thank you.
Perfect timing. Thank you so much. Up next, Community of Communities, please. You can also, you should be able to plug it in. Well, no. I don't know. And then I'm going to share the screen. Yeah. Yes. It's not working. Looks okay here. Seems to have a little bit of a lag.
Yeah. Okay, I'm going to assume it works.
Off
Okay.
you go.
Hi. So we're the Community of Communities project, which sounds quite meta. But we have built CommuneRS, which is a community of research software communities. So I'd like to present the problem statement. So if anyone has been involved with building a community building is hard. And so one of the reasons, oh, I've changed my slide and it's not picked it up. Sorry about that. Why? Sorry for the technical hitch. My laptop does not want to cooperate with sharing my screen for some reason. Like the full screen, yeah. I'm sorry for the technical problems. I'm sorry. Do you think I could maybe should we go on to the next two? Sorry. Yeah, sorry about that. I'll try and figure out a better way.
We'll reshuffle. So sorry, trying to find the right list again. Could building a miniHPC team, is the team ready? No, that is like Colin who just asked me to fix something. Okay. Press the button now. I don't know which of you would like to hold the microphone so I can do some more magic over here. Still the old timer. Ready to go. Time starts now.
Okay. It's on edge at the moment, so I'll do a switch when it gets to the end.
All right, just switch, make sure this is switched on. Speak to the, yeah. So,
Yes, you have.
I'm standing here because I need my phone for my notes and I need it for tethering. So, all right, so building a miniHPC, and Colin, next slide. So the problem started when I ran an intro to HPC workshop about a year ago, thank you, and then discovered that people didn't register their logins beforehand. The login node became unavailable and the internet also decided to play up that day. So there was a lot that could go wrong. So hence the idea of a self-contained mini HPC, high performance computer, using readily available hardware such as the Raspberry Pis, over which instructors will have full control. It is portable, as you saw. It's inexpensive, relatively, and it actually gives learners an idea of what an HPC looks like, because very few people actually get to see it in real life. So you can also create your own contained network so that instructors and learners do not need access to the internet, almost. And all of this has been in my head. And what I have documented, you needed my head to interpret it. So that's where we started today. All right, and I'm going to hand over to Loic to carry on.
Great, thanks. Oh, I can do this. All right. So just briefly on how we work today, we built three teams, three sub-teams working in parallel, catching up every hour. The idea was to focus on different aspects of the project, highlighting the transparency and coding best practice. Everything was done on GitHub, so all the modification, all the documentation was pushed on GitHub so that we could revisit later if people disagree. What worked well? Well, this parallel way of working worked really well. I think especially because we had a multi-stage testing. I'm going to get back to that in a moment. And scripting as we coded and as we wrote, that worked well as well. We had obviously working with hardware. There are a lot of things that stop working randomly and you don't really know why. And I think Colin will talk a little bit more about that. Okay, so the three main things we worked on. So as Janita said, when we started, the hardware was there. So how can we make that? Well, first a plug and play proof of concept. So if someone receives this in a little suitcase, how can they just come, plug it and play with it? So that's what Janita and Colin spent a lot of time today, and you will have a demo at the end. And then the core work was also documentation, because this is actually just Raspberry Pis and a few cables. So actually anyone could reproduce it. And as Janita said, that's a really important part of this project. But it's not as straightforward, and trainers can have very different levels of expertise. They're not all coders necessarily. So how can we make sure that it works for everyone? So that was writing this documentation really step by step, making sure it's completely foolproof. And then testing this documentation. So we had different levels of testing. So first we had multiple Raspberry Pis and three of us tried to replicate it. So I was the dummy in residence. So basically if I could do it, everyone could do it. But there was different levels of expertise before that. And that worked, I think that worked really well in terms of testing what could work and what couldn't. Next, rolling out and advertising this new documentation so people realize it's not only a single carpentry offline project, but something they could apply to anything they want. Obviously, polishing and finishing what wasn't done during the day. And the main goal is to enable sustainable, reproducible, low resource, obviously, and green HPC training applications. One of these applications is the CATS project that was part of the hackathon last year. And another one is environmental sustainability. So because of time, I'm not going to spend too much time on that. But obviously, there are lots of environmental benefits to it because it's small scales and it doesn't require kind of 1 million GPUs and can be used for training.
The demo then.
Right. just bear with me while I change to the Wi-Fi network that is running the Pi, and hopefully this will not kick me off Zoom if we've done everything right. Come on, please connect. So just to explain very, very briefly the network architecture, we have a Raspberry Pi with a flashing green light that some of you may be able to see in the front that is acting as a Wi-Fi access point into the whole cluster network. We also have that plugged up to a phone that is then connected to EduRoam that is allowing me to hopefully stay on Zoom. Am I still connected to Zoom and coming through? Okay. And I just need to change my screen share. Where's the window gone? I don't know, why can't I see that window? Let down by Zoom of all things. There we go. Right, so I am now logged into the cluster. And if I was to run, for instance, the sinfo command, it tells me that I have 5 compute nodes available to me and a very, very quick demo borrowed from the HPC carpentry material that we would be teaching. This job will very simply go and execute a very simple Python script that is going to sleep for 20 seconds. So if I run sbatch serialjob.sh, and then I look at sq, I will see that my job is sat there waiting, in fact, running in the queue. And after about 20 seconds, it should disappear from the queue. Maybe I should have made it shorter. Yay, it finished. There you have a working Raspberry Pi cluster.
Thank you so much.
Thanks.
Right. Up next is the Parliamentary Education Census team. There you go. Timer starts now.
Awesome. Hi, everyone. So we were working on trying to create this kind of census of politicians' education backgrounds. Firstly, I have to say that graphic design is very much not my passion, so these slides are not very nice, but had an amazing team that we've all been working together across a range of different things around this project. So basically, we set out that we wanted to try and improve our understanding of the educational background of MPs in the UK. So which MPs could we go to and say, we have this thing connected to our discipline. Do you want to get involved? Do you want to support us? And basically, we wanted to then build a data set that we can contribute back to Wikidata and kind of sustain and update that data set as time goes on, as elections and by-elections happen. But fundamentally, it's a hack day. We're never going to achieve absolutely everything. So our other aims were to explore and visualize some of the results, to learn some new skills, and also to have fun. Whoa, no. Everyone's tired. Okay, so we achieved lots of awesome things. We're going to rattle through. So we designed a really good data structure that helped us to bring the data in a way that's going to kind of be extensible into the future, as we want to supplement the data with more information, things like party affiliations, constituency data, et cetera, et cetera. We've built a bunch of tools using Sparkle. I mean, I'm saying we, I mean, very much, Chris in this case was kind of leading on a lot of this work, developing Sparkle queries to basically ingest the data so that when big changes happen, things move a bit more easily. And we've got a really cool API that allows us to pass this data to our front end. That, again, was also developed, and you'll see that in a second. We've been exploring some of the data as well, kind of looking at, we have a data set from HISA of every degree currently offered in the UK. So kind of looking at some of that data. We've learned a bunch of different libraries, playing with Spacey, with Fuzzy Wuzzy, with React, RDFlib, and Wikidata. And yeah, we've got kind of about 400 out of 650 MPs processed, thereabouts. Our implementation, I won't labor this, but effectively we're taking a lot of open data from different sources, flowing it through a kind of custom pipeline using different libraries and different people's expertise, pulling it through into our backend using Fast API to then pass it into React and Leaflet front end. In the future, kind of hopefully keep working on this, because this is a topic that I think, you know, is useful. It has a lot of value, and there's still a lot to do, a lot more data to process, to clean, to audit, and to visualize in different ways. But now we have a framework to do it in. So before it was just me kind of stumbling around in the dark, and now a bunch of smart people have helped me figure out what the shape of this should look like. So our next steps are to finish processing all the data, train a classifier on the HESA subject data, and then start classifying degrees into different categories, which we have done some kind of interesting work, kind of looking at distributions of different categories. So this is the 21 HESA kind of overall categories trained against or tested against different subject titles. So you see that we don't actually, with these categories, capture the full range of things that are happening in UK academia. And we can safely assume that the politicians are not doing the full breadth of subjects either. Similarly, we can look at the themes of degrees that are being offered in the UK. So interestingly, things, you know, history, media, art, politics, categories like that, super popular, but also being attacked by politicians at present. So, Tobias, do you want to do? No? Great. So we can hopefully this is still sharing. So part of our front end, and we've got our data, and each one of these points refers to a different MP from somewhere in the UK and tells us where they went to university. So the point is marking the university that they studied at. So we haven't really done any spatial analysis here. You could argue that there's some sort of geographic bias, but I think that's also a case of where universities are in the country. But this is super, super useful and super interesting. If we zoom out, we can see that we have some MPs that are studying outside the UK. A lot in Harvard, doing things in Harvard, interestingly. We also have this really great dashboard that isn't fully populated. It's just got some toy data in it for now. That currently the most popular university being the University of Exeter. That may change. As well, things like the average number of degrees per MP. We've got plans for one of these flow diagrams to explore MPs going through, as well as a queryable data set so you can ask your own questions. We also have an API, but I ran out of time. Thank you.
Thank you so much. Right. Next up, team task management for humans as self-care. And you want the slides. That's the one, yeah. Here. Right. Now it's on me to figure out how to share the right thing to Zoom. I believe that's it. Clicking should move it forward. Timer's on. Okay, off you go.
Time's on, I'm wasting time. Okay, so hi, thank you. That one. Okay. Right. Brief content warning. This does very briefly touch on issues around mental health, disability. There is a very small mention of suicide, but I'm not going to talk about it any more than this right now. So Dave Horsfall, who had to leave, unfortunately, did a mental health survey a couple of years ago into mental health in the RSE community. The text's a little bit small up there, but right up near the top is lack of control over workload. And still the wrong device. And Causes of significant stress and anxiety include things like high stress levels, project that conflict with values, long hours, problems which are often suggested to be solvable by managing your time better. And there are a lot of ways of doing this. A lot of people have made a lot of millions of dollars selling ways of doing this. Mostly those were already quite privileged, successful businessmen. A lot of survivorship bias maybe in there, in the techniques that work. And many of us are under a lot of pressure to produce more for our employer. And that is generally kind of the way productivity is taken. It's not about us, it's about them. We can't fix the system yet. This is a massive systemic issue across the entire economy. But maybe we can look after ourselves a bit better, look after each other a bit better. That's what communities are about, right? So we proposed to put together an online resource that could be used both for a workshop, but also as a reference guide, introducing some of those ideas, but contextualizing them around what is useful for us as real human individual people, and less focus on how much value we can produce. We approached it that way because, one, we don't want to reinvent the wheel. There's a lot of great resources out there. It's the context that's missing. We do want to build on that existing knowledge. And everyone in the room agreed that it was the resource we wished we had. So we thought we might as well give it a go. Design decisions, we decided to get up and running quickly. We would build on the existing Carpentry's workbench infrastructure. So we were able to get a repository up and running in GitHub, get everything deployed on GitHub pages very quickly. Thanks so much to Alexander and Ugo, who worked very quickly to get that up and running for us all to work with. That then made it very easy for us to pick a CC BY license, because that's the default for Carpentry's workshops. In terms of our working process, then being on GitHub, we had a lot of tools there to help synchronize. We were quite a large group and we were hybrid. We had people online and in the room. So having that online tool to synchronize all our work was really helpful. And breaking everything up into time boxes and coming back and coordinating. Because of the nature of the work and what drew us to it, we were quite a quiet group, quite self-contained. So it worked very well for us to sort of split up into ones and twos to work on things and then bring them back together and merge them and discuss and kind of repeat like that. So very quick demo. Look, it's up and running. It's all very, so we did enough, intentionally did enough to get an overview of what it would look like. It's all very incomplete, but it's very clear sort of what needs to be added. Oh, I've run out of time. That went well. Just imagine you've heard the other half of my talk. Yeah. Thank you.
Thank you so much. Up next, team visualizations of the health status of software or of the RSE community. Please. We have a lot of groups to go through. For the outstanding teams, running order is on Slack and in the Zoom chat, so you can. For the slide. Right. Sorry. And for folks on Zoom. Right. Are you ready? Time starts now.
Do we have 5 minutes, is it? Just to check. Okay, brilliant. So hi, we are Team Violet. Our project name that we decided on is SoftAware, a visual software health check for GitHub repositories. Oh. So the context of the project, the problem we had identified is that it can be quite difficult to get a feel or to easily understand the status of an individual software package in terms of its quality or its health, which is a term that is subjective in a sense, but there are definitely ways you can determine that something is healthier than otherwise, and we'll go on to show some examples. So we were aiming to create a form of visualization with inspiration from Ed Hawkins' Show Your Stripes global temperature display, the climate stripes, the warming stripes, hoping to display the health status of software packages, ideally in terms of a time progression. So how it's historically evolved, and hopefully that can showcase that packages have got more healthy and more high quality over time, or at least encourage things to get better. So the main benefits were a quick check and also to encourage people to think about these concepts. So our original design, this is artwork by James Byrne. As you can see here, we're taking some data. The middle format will be this JSON, which we will use to then produce the visualization from on this side.
Can you just point out that JSON is not written in my actual handwriting? That looks like that.
Yeah, we tried out some different ways of working, including right upside down. So a lot of information on this slide, so I'll quickly try and cover. I think the important thing was to choose the right metrics because obviously no way of quantifying software quality or health is perfect. In particular, we aim to use metrics that other people had already worked on and developed, not create our own, both in terms of the interests of time and to build on others' work, because they might be more robust if they've already been created by other people, and also to use a broad range because people can gamify systems when things have been quantified. They can try and get a better figure by hook or by crook. So hopefully by producing different metrics in a broad range, we can encourage that people can properly improve the quality and not just gamify it. So we've got this acronym FACTORS. These are the factors that we're including in the health that we're going to display. Some of these we haven't quite got around to hooking up to the system, I should admit. But the idea is that we'll go for fairness in terms of the FAIR principles, activity, so how actively something's maintained, community, so things like popularity, how often people contribute to that system. Popularity isn't everything, but people aren't generally going to use a software that is terrible. So hopefully that's something. Testing, how good the testing is, how comprehensive. Openness, in particular, does it have an open source license? Reproducibility, so that's is it packaged in a way that some arbitrary user can download it and run it. And security is one that we've acknowledged would be useful for some software, but not for others. So we haven't actually added that in yet, but we think that could be an optional extra. Brilliant. I'm not sure. Where's the time? Sorry. Shh. Okay, I will pass on to people. Yes, thanks to Neil and others who had pointed out this chaos resource where we got some source of information, because that was brilliant. We could build on those. I will pass over to the front end team. We split into 2 sub teams. So there's myself and myself and James working on the back end, and Adam and Anne working on the front end. So I'll pass over to the front end sub team.
That's a good sign, isn't it?
We do, yeah, live demos, and yeah, it's edgy around as well. Yeah, should I give you the microphone? I can hold the microphone.
Hello, hello. Excellent. So this is the interface here. So we basically have a little set of scripts that produce some JSON and then use Streamlit in the front end to basically go through. So the JSON then feeds this interface that the front end team did. And you can select your different metrics down here, select your different projects. So it's basically pretty extensible. The scripts can accept a dynamic range of repositories. And then we can sort of say, does a license exist, README exist, things like this. And over time, we then link the metrics that are being aggregated and produce stripes in the long run, I reckon. Yeah, that's probably it. Cool.
Yeah, thank you.
Thank you. Up next, team making runtime run.
Yeah, do you want to come over here?
All good to go? Then your time starts now.
Okay, so we've developed Algorithm, the collaborations bot, which can help any researcher with their research. So if you'd like to go ahead and just type in something that you want to know about the research you're doing there. Yeah, anything you like. There you go. Oh, hold on. What's happened here? It looks like we need to get some cooling for the data center to work. You know, it'll be fine. It's just processing. Okay. Oh, I don't know what's happening. It's taking so long this quick. I mean, we really tried to make sure that it had no impact on your work whatsoever. But okay. All right. Okay. That's good. Do you want to keep on trying out your query here? All right. Yeah. This is good. I'm sure it will run. Oh no, what's happened here now? Oh, it's we don't have enough power to run all of these GPUs. Like take a lot of power, given the big important job they're taking on, we need you to redirect power towards it. Follow the instructions. Oh, yeah, I still don't have enough power here. Okay. All right. Here we go. It's starting to run again. All right. That's good. Okay. Do you want to try finishing your research here, because your paper's due tomorrow? Try again. Oh, congratulations. There we go. You've successfully contributed to the climate crisis and the exploitation of natural resources. Thank you for taking part, Hanieri. Take a seat.
Right, so what is this all about? It's about exploring that disconnect between what you see as a researcher using a machine and actually everything else that's happening in the real world. I shouldn't have run down the stairs. So there are three roles. There's a researcher running the job. We have a facilitator that is making sure that things are done. And we have everybody else, so the real world people and the real world impact of that. And it's bait and switch mechanism, and we just want you to kind of fiscally feel what's actually happening. So, yeah. Who is it for? So we were talking yesterday about this need to educate people at various levels. So this can be used in a classroom environment. It can be used with RSE groups. Could even be used in schools with a STEM ambassador activity. Anyone that really cares about making this visible and making a difference. On the GitHub repo, we do actually have a full set of facilitator instructions ready to go. There is a slide deck to go with the web interface that you can use now. And we have full plans of how we can develop it further.
So how was this built? Well, we ran around outside for hours, what we were doing all morning, then we queried OWL, obviously. This was built on as much of a full stack as could be done within a day, using Express.js to run a lot of CSS, very pretty code to create OWL and make them work. A lot of HackMD to write and capture the documentation, hosted in a GitHub repository, of course, and the design of OWL was created in Figma, as well as all of the wonderful people in the team contributing their ideas to make this app work.
So next steps. I don't know if you could tell from how smooth and slick the presentation was, but the app isn't fully functional yet. We had to make a difficult decision just after lunch, but you know how we were going to do that. But so there's more work needed to make everything fully functional. But then beyond that, there are many other ways we could enhance it. So, for example, optional pathways, where so to demonstrate different kinds of compute jobs and different kinds of resources, different levels of resources that are needed for those. It could work in different paradigms. So VR, AR, could have a physical card game, which people could play. We needed to create a stronger connection to the literature. And it could also be, you can imagine it as a mobile app with multiplayer options, and even include wearables so that when you need that energy to run your compute job, you can run up and down to generate it.
There is links to the literature in the README on the front page.
Yes, we need stronger connection to literature, but that is it. But there is some connection there already. Okay, so thank you very much.
Please collect your water bottles.
Yes, I feel this is a health and safety hazard down here. So next up is the team drafting an AI code of conduct provision, which magically is happening from remotely. Thank you so much. Your time starts now.
Hey everyone. So we sort of renamed our session a bit to the AI Covenant, and we want to ensure before we even get started and talking about the use of AI that everything we did today was 100% human-made, as one of the judges asked us. And this was just a small group with me, Chris, and Reba in it, and we wanted to first talk a bit about the inspiration for this. So, of course, it was pitched yesterday. There was a small group of people interested, but the name for today for AI Covenant was from the Contributor Covenant, because the Contributor Covenant has popularized or really did a lot of work to make code of conducts more well-known, more integrated into open source communities. And if we could even reproduce just a slight bit of that with the AI Covenant, we would be very happy. But this is where inspiration comes from. And so what we were thinking was the AI Covenant to become sort of a drop-in experience for existing codes of conduct. So we wanted to write a subsection that people can use specifically around responsible use of AI in communities. And in order to do that today, we primarily searched for some resources and discussed ideas and wrote down first drafts, and had way too many running notes in HackMD, which we once they started coalescing, we started categorizing into different pages, started making a nice GitHub repository that runs on Hugo, so that we could generate a nice website where we could then host all of this. And we made sure that once we started porting everything over, there were still some things that needed to be resolved and some discussions that we needed to have. And we documented all of these through pull requests. So if you go in, you could see all of these specific discussions that we had. Again, we were a small group, so it was just the two of us, but it's all in there. And so throughout these few hours, it was very nice, because when I went to lunch, Reba continued working. When Reba went to lunch, I kept on working. So we had a very nice cadence in that sense. But you can now go to ai-covenant.netlify.app, and you can actually find the AI Covenant. As mentioned, 100% human-made, still version 0.1. Also to indicate this is still something that can develop further. The language is not final, but we wanted to make sure that today it's not just adding more tasks to our plate for the next weeks. So you can go there now, and you can also find all the contributors and join the discussion if there's things that you see that work, that don't work. In the future,
we of course want to get this to version 1. And once we hit version 1, we also want to translate it into different languages so that it's more accessible for non-English speaking codes of conduct. And yeah, we want to keep it 100% human-made because it's something that we're not sure who is participating. And if you read the AI covenant, you'll also see that a big part of that is consent with regards to using AI. So this is the website right now. If you love dark mode, it's also in there. Nice plus. And I want to thank all of the contributors. We also made sure to give credit where it's due. So I think Matt, Eli, and Thomas, they discussed this before, and Eli especially yesterday pitched the idea. So thank you very much for that. And so you can find the AI covenant on the web now.
Thank you so much, Chris. You can't hear the applause in the room properly, I think, but thanks tons for that and for catching up a little bit with the time. Team RepliMAT.
Thanks. So let's just go straight to our picture of our team, just because they're the most important folks. We've got Paddy, Dan, Gaurav, and our giant floating head, Michael. This is extra exciting for me because RepliMAT's been a thing that's kind of been a bit of a brainchild of mine for a little while now. And this is the first kind of community effort that has gone into RepliMAT. So it's been super, super exciting. So I kind of proposed yesterday that we do something to do with this project, but whatever it was that the team wanted to do, I didn't want to dictate anything myself. I'm far too deep into it. So the kind of problem in general about that RepliMAT seeks to solve is that MATLAB is really, really popular with researchers. It's not really, really popular with RSEs. And as a result, there's really limited guidance on good practice in comparison to lots of other tooling out there. So there's a lot of MATLAB-based research that could really benefit from some extra guidance and become more reproducible and sustainable. And the RepliMAT itself is a kind of piece of guidance for researchers in the form of a handbook and course and reference manual. Today, we kind of chose to work on a particular nugget of the whole project that the team came up with, which was to arrive at a template for project organization, kind of for specific tooling and things that are specific to MATLAB. So first of all, we went about adding a chapter to the book, and just because the last presentation did it as well, we've also got dark mode, but that was there already, but just got to show things off. And so we added a chapter, and we've got some nice author acknowledgements there, and that explains a little bit about project organization and specific concerns for MATLAB. But the real bulk of the work today was in generating from absolute nothing. I was absolutely astonished by this today. A whole template repository in GitHub. So if you're not familiar with template repositories, these are repositories that you can effectively copy to your own project. And this one contains mostly kind of directory structure to organize your thoughts as a researcher into a way that encourages better practice. So that includes separating your raw data from your process data and encouraging people to only programmatically affect their raw data. It encourages them to create all the good stuff like docs and tests. We now have CI that runs MATLAB tests, which I think is not even known that that's like a real thing that you can do, and we can do it in this project already. Things that kind of emerged out of looking at this project today were that MATLAB dependencies are like super heterogeneous, and so there's kind of no one solution for documenting or capturing those. And actually, what we can do with this template is create visible gaps in the kind of README and things that encourage researchers to document all those different types of heterogeneous dependencies that have to kind of be done manually, or at least that's the kind of solution we can come up with so far. And the other bits that I was going to talk about. Anything I'm missing out? Okay, so this is ready to go. We kind of arrived at like a manageable chunk that we could fit into the Hackday today. And this is kind of, barring a tiny bit of like tidying up around the edges, is ready for researchers to go and take on and start using. So that's super cool. So thanks everyone, and especially to the wonderful team who got all this done today.
Amazing, thank you so much. And last but not least, we're gonna try community for communities again. If I find the
presentation.
Right. Full screen and share that hopefully to Zoom, and do you want to see if that moves around? Wonderful.
Okay, are we starting the time?
Yes.
Okay, great. I hope you forgot everything that I said before, and I'll start afresh. So we're CommuneRS. Our project is quite meta because we're talking about a community of communities, and CommuneRS stands for Community of Research Software Communities. So the team that we brought around this topic for the Hackday are really passionate about solving this particular problem, which is, if anyone's involved with community building, it's hard. So we're thinking about answering questions about how we can form a community that provides opportunities for community leaders to network, collaborate, and support each other. And we want to address how community leaders can avoid the feelings of isolation sometimes that we have. We want to avoid reinventing the wheel, and we want to share knowledge and provide support across communities and build those connections. So this is our team. We are a wonderful team of 9. And it's been really great working with them. So this is our team photo. We have a hybrid setup. So Ella, myself, Alessandro, Dimitri were involved with retrieval of data from various sources. Saranjit was naturally a really good project manager, and that came out in our workflows and how we created issues and merged pull requests. So thank you to Saranjit for that. We had Michelle, who was participating from Australia, and it was her bedtime. And she was contributing resources, and we were able to accommodate for the fact that she wasn't so familiar with GitHub by encouraging her to post all of her resources into a Google Doc, and we helped translate that into the product that we built. And Ella and Tomas were our resident R experts who helped us create the Quarto website. So yeah, kudos to them for doing an especially heavy lift when it came to building a website in the space of 5 hours. Finally, Adamu helped with creating the presentation pretty much from the offset. So that was really nice. And also a credit to Tomas as well for building a wonderful hex sticker as well with the hex sticker package in R. So as I mentioned, we created a website for communities of research software communities to convene. We're very aware that we can't hack a community together in one day, but the first port of call that we thought would be reasonable to address in a hack day is creating a database or like an index of research software communities that, you know, the nexus of the Software Sustainability Institute branches out into. So I'm just going to, hopefully this works, click onto the website. Okay, hooray. So we have our index page that really motivates why we're here. So we're not here to actually provide training. We're here to build those connections and form those bridges. So if you go into the Communities tab on this website here, you can see some of the our index that we've pulled together so far, and we really encourage you to contribute as well to software communities, research software communities you might know of. And what we've done is provide a basic description, a website link, and the reach and region, as well as tagging each community by a theme. And so what people can do when they visit the website is perhaps someone is interested in EDIA. So they can filter this table on that particular tag, and then they can find regional or international communities that are focused on these efforts. So it really helps with people who are starting their community building project in discovering other communities. And then, yeah, we've got a space for curating a comprehensive list of resources, because the real value that we'd really like for people to take away from this particular project is to share contextual examples of community building, because every community is unique, but we obviously want to find some overlaps and try and share common experiences. And so lastly, I'm just going to show you our GitHub repo, which has evidence of our good research software practices. So we've got a few issues left to close, and you'll see our various pull requests. And then heading back to, is that time over?
Yep.
Okay. All right. So I'll just leave up our future steps up on this slide. And thank you for listening.